So in this triangle here, we want to determine AB, CD, and BC. So to get AB, I'm going to use this thin triangle at the front here. Now if this is 52 degrees, this angle here must be 180 take away 52, gives me 128 degrees. And then we know that the three angles of a triangle add to 180, so if I do 180 take away 35, take away 128, that leaves me with this one up here being 17 degrees. Now I'm trying to work out AB, so I'm going to first of all say the variable is x, but I'm going to label it as side A. I'm just going to ignore this labeling at the moment. My own labeling, which is obviously in a different colour, means that this angle up here is now A, if this side is A. Then this I'm going to call B, and this one's already called B, so that's all good. But remember, you can relabel triangles as much as you like. Just don't obliterate the labeling that you're already given in the question, because you need that to refer back. So we can use the sine rule on this. Again, you could use that table layout, but I've done that in the last few examples. You don't need to see that again. So A over sine A is equal to B over sine B. So x over sine 17 degrees would be equal to 35 over sine 128 degrees. So I can use the E-activity for that. So I'm going to go to E-activities, and of course I'm using the sine rule. So I'm trying to work out A. I know the angle A is 17. I know that B here is 35. Angle B is 128, and that gives me A is 12 point, let's write that as 986. So x is equal to 12. What I'm going to do is I'm going to give it as 985,876. And then say that that's equal to 12.99 centimeters to 2 decimal places. So I'm giving it as a final answer. Okay, so I'm just going to clear off the information I don't need again for the next part of the question. And what have we just worked out? We've just worked out that this one is 12.99, but of course we've got the extra decimal places because we don't want to build in inaccuracy by using this rounded figure if we need to use this one again. Now the next thing we want to work out is CD. Now we can use the right-angled triangle all the way around to do that, because we know this angle. In that triangle, well, let's say we're just trying to find this one, which is Y. And this is the hypotenuse. We know the angle is 35, and this one is the opposite. So we can use the sine. You could use the sine rule as well, it doesn't matter, but we may as well go back to right angle triangle trigonometry when we've got a right angle. So, car, toa. Opposite and hypotenuse, we're using the sine. Sine 35 degrees is equal to y over 35. And since I'm right here, I'm just going to use the activity for that. So my angle is 35. The opposite is what I'm trying to find. And my hypotenuse was 35. Trying to find the opposite. Solve. So it's 20.075175. and I'll say that that's equal to 20.08 centimeters to 2 decimal places. So finally we want to find BC. Let's call that one Z. Now I now know this one, don't I? It's 20.08. And so in this right-angled triangle we know enough information. The 52 degrees we know, this is the adjacent and this is the opposite. If we use so, car, toa, opposite and adjacent means we're using the tangent. And the tangent of that angle is equal to the length of the opposite, which is 20.075 and so on, divided by the z, which we're trying to find. But we can use the activity for that as well. So, notice how this is highlighted, and it's actually the value I want. So I can actually copy that. And we're using the tangent. We know the angle is 52. The opposite is exactly what we wanted. I didn't need to paste it in there, it was already there. And we're trying to work out the adjacent. And so we just hit solve on that, and it gives me 15.68. Now we're not going to need that again, so I can actually round that straight away to 2 decimal places.